Hey, hi friends. My name is Ajay Dwivedi, and today we are going to talk about the next dashboard that we have in SQL Monitor Infra. Just for recap, SQL Monitor is a tool that I have designed using PowerShell and Transact SQL. And using this tool, you can baseline all your SQL servers ranging from SQL Server 2012 and up. It supports all versions of SQL Server. That includes Developer Edition, Enterprise, Standard Edition, and even Express Edition. So, thanks for joining. Let's jump on to next dashboard. So, on Grafana, again, as usual, I am going to open SQL Server folder. Within this, from top, the fourth dashboard which says WaitStats is the dashboard that we are going to talk about today. Like earlier sessions, I am going to use our SQL practice instance for discussing the metrics which are being presented on this dashboard. So SQL practice instance is a particular SQL server on which I usually run all kinds of workload for my testing. So as you can see, the server has been up and running since 9.72 hours. So there are three rows in this dashboard. Row number 1 shows you the wait stats since the startup of the server. Now, along with that, you even see the basic details regarding the server. For example, how many CPU cores are there for SQL Server, or in other words, how many CPU schedulers are there for being used by SQL Server. And this is fully qualified domain name of SQL Server along with IP. The header says wait stats since startup, and that's what the result is all about. So the server has been up and running since 9.74 hours. The top wait in those 9.74 hours has been page IO latch, that contributes to around 46% of overall. Similarly, the second top wait type is SOS scheduler yield, that contributes around 32%, and the third one is CX bracket MS SQL XP as the subsequent one. So what is the use of wait stats? If you have been following blogs, or if you watch YouTube videos, or you attend some training sessions, past summit sessions, in every sessions, every instructor talks about how to performance tune, or where to start the performance tuning for your SQL Server, and they all point to the same thing, that is wait stats. So that is the importance of wait stats on SQL Server. Whenever a session or a request is not running on CPU, then it records its time when it is not running on the CPU. So it records its time for a particular kind of resource, why it is waiting. For example, if a session needs some data pages to be brought from disk into memory, then it will say that I am waiting for data pages to be brought from disk into memory. If it is waiting for CPU, then it will record different type of wait type. If it is getting blocked by some kind of, if it is getting blocked by some for some resource, then it will register wait type for that kind of resource. So for every kind of wait, we have wait types in SQL Server. So overall, this is how the wait type looks like on my SQL practice instance. Server has been up for 9.74 hours, and the top wait type is page IO latch SH, and the second wait type is SOS scheduler read. So what this tells me is, out of 9.74 hours, my server has literally spent 2 hours only on page IO latch wait type. That means the workload on my server, they are reading data from the disk, and if I have to start troubleshooting on the server, I should do something in terms of indexing or query training, so that we can reduce the IO that is happening just because we are bringing the data from disk into memory. So the whole focus in this case, if I have to troubleshoot my server, is the queries which are reading a lot of data. I have to start with those queries in this case. Once I have tuned top queries which are reading lot of data, then I can go ahead and focus on SOS scheduler yield wait type, which is which represents that queries are waiting for CPU to run. Okay, so how it happens is, you run a query, it runs for it gets 4 milliseconds of time on CPU scheduler, and then it voluntarily steps down and goes into runnable queue. So during this time, when the session or request is in runnable queue, at that time it records the time as SOS scheduler yield wait time. So in short, this wait type directly indicates CPU pressure on the box, or CPU pressure on the SQL server. So if SOS scheduler yield happens to be my top wait type, in those cases I would look for the queries which are consuming high CPU, and I want to start tuning them. Now, this was all about the first row, which shows the wait stats since startup. Now, in my case, what happened is, I ran the workload, not normal workload, some time back for 1 hour around, for 40 minutes around. So I want to see what I can do to what I can do to improve the performance of that particular workload, which ran for around 40 minutes. So first thing, this time I'm going to use the old dashboards to give you demo how these things, how these dashboards help you in combination. So first, let me open this particular dashboard which says monitoring live distributed. We already discussed about this dashboard in previous sessions. I choose my server SQL practice here, and what I am going to do is, I am going to say show me stats for last 6 hours. I am more interested in finding out when there was a outlying CPU utilization which does not seem to be normal. So you can see here on this SQL practice SQL server instance, CPU was high, at least it was way above than the normal values during this time frame. So what I am going to do is, I am going to select this time frame here, and now I can see the time frame that I am interested is 9 PM 25 minutes till 10 PM 7 minutes. So I will return back to my old dashboard of WaitStats, and I will select the same time frame here. So today is 22nd September. Then we are interested in 9 PM, that is 21. Then we are interested in 25:00, and here I want to say 22:07. So the first row will always represent the data as per its name. So this first row data will never change, irrespective of what time frame you select. Okay. So this first result will always show the wait stats, how it looks like since the server has started. Now what we need to do is, we need to go to the second dashboard. Second row. In the second row, we have two particular panels. If you go dig deeper into it, so the header of the row is selective wait stats. So what this selective means is, there are two panels within this row. The first panel shows the wait stats starting from the starting of the server up to the time, whatever you have time selected. So that means server started around 9 to 10 hours. So from that 10 hours long time till this 9:25 PM, that wait type is being shown in this first panel. So This second row represents selective wait type. In that second row, the first panel represents the wait types since startup, but before the duration that we have selected here. The second panel in this row shows you the wait time that has shows you the waits that have been collected during this time interval. So the time interval that I have selected is 9:25 p.m. till 10:07 p.m. So for around 40 minutes, whatever waits got collected, we can see here in this second panel. So now if you compare these two, you can see a big difference in terms of what wait types are the top wait types on the server. So before this duration, the usual wait type was MS SQL XP. So for 8.33 hours, the top wait type was MS SQL XP. And if you see waits per core per minute, within a minute for a single core, for the top wait type, we only collected 60 milliseconds. So in a minute, that means 60 seconds. If you calculate that 60 seconds or 1 minute into milliseconds, that becomes 600 seconds. So out of those 600 seconds per core, the top wait type has only collected 60 milliseconds. It seems that during this time frame, my server was not doing anything at all. But if you check the second result set, second panel result set, then here the entire theory changes, entire story changes. The top wait type, which was recorded to be page IO latch SH within this 30 to 40 minutes of time interval. In that 30 minutes of time, just for the top wait type, in per core per minute, we have collected around 45 seconds of wait. So for 60 seconds of wait time, we have collected 45 seconds of wait for the top wait type. So that means there was something unusual running on the server which shifted the entire wait type on the server. So if I have to troubleshoot anything, I will first look at the workload that was running for this time frame, because that was not a normal workload. Normally the workload that runs, it generates these kinds of wait types. But the workload that was running during this time frame, it generated different kind of wait types. The top wait types totally changed. The top 3 wait types totally changed between this duration. So to conclude this dashboard, what we can say is, usually the server does not have any kind of issue in terms of performance, but during this time frame, there happened to be some kind of workload that did a lot of data reading from disk, and due to that other people suffered. So if I have to do something about it, I will look for the queries which ran into this duration, and specifically I want to focus for the queries which did high reads. So that was all about the second row. Now let's talk about the third row. So in the third row, we see the same WaitStats information, but in histogram format like this, in vertical bar charts. So I am going to change the duration again, and I am going to make it 12 hours. So there you can see, usually on our servers, so the data collection started around 1 p.m. in afternoon. That is the time when I started this server. Earlier it was in shutdown state. So from 1 p.m. till 9 p.m. in evening, the usual workload that runs on the server does not cause any kind of issue. You can see the vertical bars that are there, they are literally not showing any kind of data, just because the values or wait stats that were collected during that time frame are nothing compared to the wait stats that we have collected just in 40 minutes. So what this particular row indicates is when you change the time frame for longer duration, you can see the outliers, what happened at what time. So here you can see usually the server was performing really okay, but there happened to be something wrong between this time frame from around 9:20 p.m. till around 10 p.m. 10:20 p.m. So between this, there some kind of workload ran, and it caused lot of wait stats to be generated on the server. Now, if I have to go deeper into this, I will look for the color, the top color, which is representing most of the area in these vertical bars. So I can see this violet color. Let me zoom in to this dashboard. So I can see this violet color is the longest color in these vertical bars. So what I will do is I will simply come here, look into these legends that you see on the right side, and the top one is having the same color. So directly I can say that the top wait which collected during this time frame was page IO/SH. That means whatever workload was running, that was reading a hell lot of data from the disk. Similarly, the second top wait was SOS scheduler yield. That means whatever workload was running, it was consuming lot of CPUs also. So it went, consumed 4 milliseconds of CPU time, it stepped down, went into runnable queue, then it again went into the CPU schedulers and consumed 4 milliseconds. So this way we did we generated a lot of SOS scheduler yield wait type also. So that's all about this particular dashboard. To summarize, we have 3 rows in this dashboard. In the first row, we have only one panel which shows you the how the wait stats look like in a tabular format since the server has started. So if I have to troubleshoot a particular server without knowing a particular time frame for which I am looking for, in that case I will look only for this particular row and this panel, and I will go ahead, look at the top wait type, and I will whatever top wait type is, based on that I will start looking for queries and tune those queries. One more feature that I have added here in these dashboards is these are all clickable links. So the wait type is a clickable link. If you click on this wait type, then it will take you to the SQL skills website, to the blog post by Paul Randall. So Paul Randall has almost documented all the wait types on SQLskills.com. So if you click on this, it will take you to that website. So I clicked on the top wait type, that was page IO/, and after clicking that row on page IO/SH, I will land up on SQLskills.com blog, which describes the details about page IO/SH. The second panel was all about selective wait stats. So in the second row, the first panel indicates shows you the wait stats that got collected since the startup, but before this time frame, whatever time frame you selected. So if I select last 1 hour, not just 1 hour, last, just say 90 minutes rather. So if I select last 90 minutes, there you can see. So since startup, before last 90 minutes, this is how the wait stats looked like, and in last 90 minutes, this is how the wait stats looked like. So this way you can differentiate between the workload that was running on a particular time frame if you have to troubleshoot a server for a particular time frame. The last row has only one panel, and that gives you a nice histogram of the workload how it looks like on your server. So if I change it to 180 minutes, there you can see usually the workload on the server is normal, nothing unusual runs on the server. But during this time frame, there was some kind of workload which did a lot of I/O and consumed a lot of CPU. So that's it regarding these dashboards. Thanks people, thanks for joining. In the next session, we will explore the last dashboard that we have in SQL Monitor Infra. And then we will look in further sessions, we will explore, we will look into the demos on how to set up SQL Monitor Infra on standalone servers first. Thanks folks, thanks for joining. If you like the video or the tool, please do like and subscribe these videos. Thank you.